Okay, it appears that I never did write on the board the answer to the question when 69% was to the right. We transitioned to the question of when 75% is to the right. So what if the question had asked about 75% rather than 69%? And there was a reason for doing that. It's because 19% happens to be something that many of you know about. So we kind of had to switch gears a little bit, okay? So everybody did do an estimate for 75%. So we draw the curve and we do this, and most people got an estimate around negative 0.6, okay? Now some people had like negative 0.9, some people had like negative 0.5, but negative 0.6 was kind of a fairly typical estimate. Okay, well, how well did that estimate work? Okay, well, we go to here. Our estimate from the picture was z equals negative 0.6. So what do? We go to the table, we look up z equals 0.6, and we find that the area between the middle and z equals either positive 0.6 or negative 0.6, since the curve is symmetric, that the area is 0.226. Okay? Now, how does that compare with what we need? Well, if 75% is going to be to the right of where we divide it, then since 50% is to the right of the middle, 25% has to be between the middle and where we cut it. So this region has to have an area of 25%. If we cut it at z equals negative 0.6, we get an area of 0.226, which is close to that 0.25. Okay? To find where we have to cut it to get 25% of our area, what do we have to do? Well, 0.6 isn't far enough to the left. We've got to go a little bit further left. In order to figure out where we need to be, don't we need to find the z value for which the area is 0.25? Okay, so I'll make a little note of that. So we're going to have to find the z value that gives area 0.25. Well, the table has two columns. It has a z column and it has an area column. And we know what z goes with what area. So if we look up an area, we'll be able to find out what the z is. Well, the area we need to look for is 0.25. The table will tell us for what z value the area between the middle and wherever we cut it is 0.25, and it'll give us that z value. So what do? We find a equals 0.25 on the table, and we see that the closest value to 0.25 under the area is 0.249, and that goes with z equals 0.67. So we conclude that the closest z value is 0.67. Now, the z value for z equals 0.68 is 0.252. You could interpolate and say, well, that means z must be a third of the way between 0.67 and 0.68. If you don't understand what I just said, ignore it. But some people will. So yeah, you can interpolate it, but you don't know what number follows the 9 here, and you don't know what number follows the 2 over there. So we're going to do well enough if we do z equals 0.67. And if we want to refine it, we can get on the internet and find a z table. We can find a z calculator. We put in the area, it'll tell you z to, as many significant figures as you want, most likely. Okay? Anyhow, using our techniques, and I just realized that I put a test in there and didn't attach the z table. I've got to fix that. And it's too late today to fix it, I think. Anyhow, it's a little disconcerting. Okay, again, We need 25% here for reasons that you to understand. We want 75% to be to the right of this, so we have to have 25% here. So we look up area 25.25, 25%, and we find that Z is about 0.67. So there's our Z value that corresponds to the condition 75% of the curve is to the right. Okay, well, we still have to deal with the x equals 127, okay? We haven't dealt with that part of the question at all. So we'll come back to that in the next video. I'm going to run quick over to the testing center and see if we're still alive.